action. I will record it. Those who will miss the chance to attend for the session to go through. So you can watch details about what I have presented on the section on interaction modeling and design. This is the things which are presented in these sections are very useful for both the interaction design as well as a user experience side. So I'll briefly summarize what comes in this section. So here we expect to discuss some of the very important two concepts comes in the user experience design, that is also known as the two gulfs of interaction. So we will define them and we'll see in the course what are these two gulf of interaction. Gulf means here kind of the main gap or issue that what we can see in the interaction that affects that will result a kind of a human error in some cases. So we'll discuss the details and you should be able to describe them as a part of a learning outcome. Identify the importance of the ergonomics to minimize the bad effects. I mentioned this word ergonomics. I think it's a kind of a universal principle. Whenever we do or produce some design, it should design in a way where others can use it without any problems. Sometimes some products, some services will result injuries. Okay, I mentioned this one even the last time when we talked about when users are using a keyboard, if they don't follow the proper approach or method, that will lead to a kind of a problem. So we call this ergonomics here. What are the principles things should be done in order to minimize the injuries for the end user? So that's important to discuss. So that's another next learning outcome. The third will be the different interaction styles and the paradigm. So we'll discuss about what are the way things have evolved. In fact, with respect to different modalities of interaction, we call them as an interaction styles, and they have changed a lot. Now, the way how we are using a mobile phone, a smartphone is different from a way we are using a laptop or desktop, even other computing devices. So these things change. It depends on to some extent based on the technology. On the other hand, things change from one generation to another generation. So, and also at the end, important components of the graphical user interface design, known as a Vim components. Vim stands for the thing called the Windows icon menu pointer. That's what stands for the Vim. So those are the four main components which used for the interaction design will be discussed here. So those are some of the key things that I expect as a learning outcome in this course. At the same time, we'll discuss some of the other stuff. By the way, while I'm doing this one, if you have any question, you are free to at any time to put into the chat box. I am checking from time to time, and at the same time, you are welcome to unmute and ask any question verbally, because already I hope that you may have gone through. My objective here is just to summarize what is expected in this section on the interaction design, modeling and the design. So when I say the modeling, I mean what do you mean by the modeling? You have any idea? What is this the same or difference when I say modeling and the design? What is a modeling? What is the design? So how they are different? you have any ideas, just type it on the chat box at least. How do you describe modeling? Of course, I guess you may know the design. Design means it's a kind of a solution for a given problem. We design a particular thing as a solution, okay, for a given problem. So that's what we can simply describe as a design. So what is modeling? One thing is says computer model is something analyze historical data and the predicts results. Yes, computer-based model, one of the feature is that one. You are correct. I mean, it is possible. I mean, if we design in some models, you can use those models to analyze data, and you people can use those models to describe the things in detail or identify its behavior. Many analysis could be carried out. But I am talking about a modeling activity, okay, which happens just before the design. Okay, in fact, sometimes we call modeling is a part of a design. Uh, it's a kind of an activity people do it maybe at an early stage of the design. Okay, now let me take a simple example. Suppose you wanted to uh, develop, let's say, a vehicle, uh, a new vehicle, a vehicle you wanted to design, you want to develop. Okay, so before designing, there may be problems which is not very clear to you. There may be other things, but then one of the ways to will be, because it's a very complex thing, people may come up with an overall small structure. Okay, people want to create a structure, the base structure. So this base structure, probably not the solution, not the design. It's the something the people may use to develop the design. It's a something like a foundation in a house. Okay, people may wanted to set it up, and then the design may be built based on this model. Okay, so modeling is kind of thing. Sometimes the people develop a prototype to test whether this model is acceptable, it's suitable or correct. So please just keep those, I mean, the fundamentals things very clear. What do we really mean by the modeling? So the designing or design process is a complex task. It's a very difficult, but if we have a good foundation for it, and we model, the model will provide that foundation. So modeling is an activity that will help us to do it. So that's it. If you have any question, please tell us. So this is the lineup in the section. It describes some of the basic models. Okay, how people describe the models, different models which are related to the in the literature which is available as for the interaction. Then what are these two gulfs which I mentioned earlier? Then describe about the human error. And the main reason is actually to minimize the human error, unavoidable. Human error is an unavoidable that we'll have to face it. However, we can minimize the human error by creating good interfaces, good systems to do that one. Ergonomics, I'll introduce that one. There are interaction styles, and then these window. All these things I have recorded, so don't know whether you've gotten a chance to go through them. I say it's better at least that you first could browse the slides and then listen to them carefully if you can find the time. So here I am not going to repeat everything, but I will just give an overview. Interaction with the computer and system. So I mean what we have seen today, people or the user interact within a system. Okay, the system contains not on a one computer, many computers, and sometimes we have a what we call the many users. So the interaction, communication within a computer or systems will have to see um, many to many thing that happens in a working environment. So when I say many to many, it may be many users. I mean, the interaction may be through with among the many users at the same time. Many computers, many systems also could be possible. And I mentioned about the last time about the batch input device, highly interactive device. So I'm not going to talk about that again today. And modeling human computer interaction is very important because if I say again, the most important part is the in a particular system, its interface. If the interface is poor, the people find very difficult to use it. And then what really happens, then uh, uh, people may refuse to use, so people may fail to use it. As a result, the product will come to its end. Its end means if people are not using, that is the end of the product. So there may be, it is not technological changes. It may be, or it may not be, and there may be, the system may be very good. It may have no problem. But if the interface is bad or poor, people will fail. So then our main objective is to have a good interface. So in a good interface, what to expect is interaction. So that is what we have it in the high level way. However, if we really wanted to look at, irrespective of a specific systems, how do you look at, how do you analyze those systems? So these three models are described them, and among them, this is the most popular approach people use to describe a good interaction, a model for good interaction. So irrespective of a specific system, anything, we will be able to describe using this model a particular system. Okay, let's look at the details. First one is known as a GOMS, goal, operators, method, and selection. So GOMS model, it says the way things are happening. I mean, it's not an arbitrary thing. So always people have a kind of a goal. Okay, what the user intends to do. I mean, the interaction, before the interaction, there should be a goal. And then if they have a goal, they need to, in order to achieve it, people use the operators. So operators are kind of an action performed to reach the goal. Okay, it's the basic things. And probably people, it's not one action, people may have to do series of actions. So that is where the sequence of the operators to accomplish the goal. So several things. And this is kind of what we call the methods are described or defined based on it. Okay. So the selection rule, how the user selects the method, okay, is a kind of a thing people do it. Now, if I take the simplest example, suppose you wanted to go to somewhere, let's say Kandy, you want to go to Kandy, and then probably that it may be your goal. Then you may select different actions. Okay, you may want to go to the bus stand and then take a bus, and at another place you may have to change the bus, and there may be several actions you have to do. So you'll have to identify. If you are using a public transport, it becomes the one operator, and probably if you are using a private transport, that will be another operator. So like that, there may be several, and then you sequence them. And also you may have some set of rail. Okay, you may want it to go at one particular time to one place in order to get the bus, or then you are planning, your rule set will be there. So whatever the things we do in the even the normal life, this model could be used to describe them in a very abstract term. So this is what we call usually a model. So goal, operator, method, selection are the 4 steps people could describe in a very high level any interaction that could take place. The other one is the second one is called the KLM method model, keystroke level model. I mean, everything happen, people visualize things happen through the keyboard. Okay, and that's where people describe, define an average time for a general operation, code an action using general operation, calculate the time. So even if people have to type how much time the people usually have to do, how many steps people will have to do. In abstract terms, people describe that model. Okay, so this I'm not going to discuss this, already explained in detail. So look at this. This is another keystroke level model. So the people try to visualize how the keystrokes work on there. So next I have explained about what is a model, which I just explained at the beginning. And biggest advantage of a model is it helps us to visualize the solution in a very easy way. So two parties, the system who have no common language to communicate interaction. So this becomes a complex communication, complex process because of that thing. So interface is doing the translation. So that's why we really need a kind of a model. Models of the interactions and details are given. So I skip. And this is another thing, language of the communication. I mean, it's good to understand, as we always say, computers don't understand the human languages, they only understand the machine language, and the users don't understand the machine language, they understand the human language. So the communication happens through the kind of a language, but here the 2 languages. So in the HCI context, we define machine language, or the language of the system, as a core language, and the language of the user, so the human language, so maybe the task language. So probably this representation will help to do the translation process easier. And then I have taken an example, so you can watch the video to see how that example works. Okay, and yes, then this is the most popular model for the interaction, where people talked about the user executes a plan of interaction, it's executed at the computer. So it has a 7 stages. So interactive cycle has the 2 stages people talk. So the 2 stages are the execution, and the other one is the evaluation. We always do something, that is the execution, and then we look at the result and then evaluate that results to decide the next steps in our series of interaction. So these are the main 2 things, and it has a 7 stages based on that, where the first user establish the goal, then people establish the intention, specifies action at an interface, execute actions, perceive system state, interpret the system state, evaluate the system state with respect to the goal. So it described in this diagrammatic way, where the goal is a starting point and the execution happens. I mean, even when the people want to do something, they look at the interface and trying to identify what are the things the user can do based on this background. So that is the execution part. he will do this operation on the systems, then the system reacts, will show some messages, some status will change, and the user evaluate. Okay, and after evaluation, in order to reach the goal, the user may again repeat the execution. So this may go in a cycle until the user reach his intended goal. So the first thing, in order to do that one, always there should be a goal. So interaction doesn't happen without any goal. Everything in the whole world, there isn't a reason for it. Okay, goal, that's what we define as a goal. Then in order to reach the goal, if the people want, they formulate intention, specify actions, execute actions. So this is the first stage. And then the perceive the system state. So they try to understand, and then they interpret this one and evaluate the state. So and see whether they evaluate with respect to the goal. If not, go back to the first. So this is the kind of the goal is related to the here, and the execution is related to these 3 steps. You can see evaluation is related to these 3 steps. Okay, and so this circle goes like that. So this is the what is known as a Don Normann's model of interaction, the most popular model for the interaction. And then it comes to the 2 gulfs of interaction. It's very easy to define now. It's based on it's a problem people face when they want to do something. And probably if people struggle to do something using the features available on the interface, it become failure. Now, if I take a simple example, if you have used I hope everyone have used this paint software, which you can use to draw something, and also the Photoshop or Illustrator, this sort of tool like that, and a very advanced tool for drawing and image editing. And if you have used those things, I mean, the interfaces are very tough, and people need to have some understanding how do you do some work using the Photoshop or Illustrator. But Paint, people don't need any special training. It's a very straightforward. When they looked at the menus and the other things, people can easily do it. So gulf of execution is measured with respect to a particular goal, whether the user will be able to do that. And if the interface is poor, then the user struggles. So that means, in other words, this gulf will be larger than the expectation if the design of the system is poor. Evaluation, I hope that you can now easily understand, is an opposite of that. When outcome is difficult to evaluate, if the people don't understand it clearly, then what happens here? The evaluation fails. So these are the 2 things what we see in general. And as you can see, the physical systems and the goals, and this gap, if this gap is larger, then the end users find very difficult to use the system. So we may say it is not a user-friendly system. And people with that, people face kind of a problem. So the designer's responsibility is to reduce this 2 gulf. I mean, in a simple terms, easy to understand and easy to use and easy to understand. So people can do it. The perfect systems will happen. Okay. I briefly mentioned last time about the mental model, and the mental model has a direct effect on this 2 gulf of execution and interaction. So how? What is a mental model and how it is related to these 2 things? I like to ask it as a question from all of you. Any comments, any ideas, any suggestion? Just say what you understand. How the mental model affects the two gulf of execution and gulf of evaluation. At least in one thing, how the mental model. Suppose if I ask this question even in the exam, how the mental model affects the gulf of execution, how are you going to answer it? I'll give it 1 minute to think about because I wanted to have a glass of water. Okay. Okay, I have a few answers. Finding out the system user already is familiar with. How do the user use the system? Yeah. What is the current state of the system? He defines the mental model as is based on the user's background. So, mental model vary from one user to another user. Mainly because their background may be different. So, here, suppose if a person is an experienced user who knows how the system works, so then it will be easy for the person to do some work. Now, I earlier said paint is an easy one. I think most of the time, I mean, the people, irrespective of a background, if the person can just use a computer, I mean, it may be very easy for a person to understand. But if the person doesn't know about how to use a computer, the paint will be again difficult thing for the same person. That may happen. And the same thing comes on the Photoshop or Illustrator. If the person has a previous experience of using the Photoshop Illustrator, he can easily understand the interface and he can do the work. So the mental model describes his experience as well as what he knows, his knowledge, experience, skill, everything. And that affects the interaction. So user experience, in other words, affects the interaction. So the gulf of execution is something that is not a fix for all people. It varies from one user to another user because of this varying mental model in the all of us. And there are 16 people in the session now, including me. So we may have a different mental models. So as a result, when we have to do something, the graph of execution will be different. And the same comes with the evaluation. Okay. People may understand the messages, what appears on the screen very easily, or they may not understand easily. So both could happen. Yes. So bridging the gap of execution is a responsibility of the designers. So the good designs is required. And on the other hand, the good designs depends on the selected group of users. So that's what we will discuss later in detail in this course. Yeah. So I have described some of the things in here in more detail. And among them, there is another important concept called the WYSIWYG. Hope you may have heard about. How many of you have heard about it earlier or some courses? WYSIWYG. WYSIWYG stands for what you see is what you get. Can you raise your hand? How many of you have heard the concept called the WYSIWYG in a previous course or at some place? Okay, can see one person. Others? Okay. WYSIWYG stands for what you see is what you get. I mean, it means we always look at something. Okay, thank you. And try to understand from what we know. Okay, and we are trying to interpret based on the way we see it. Way we see it is always, I mean, the visual we may see a particular object, but the two people may interpret in a different way. So when they interpret and they will, based on that, people start use it. People try to start interact. So what you see is what you get. Now, for example, I remember lots of people started looking at the computers at those days like in another TV, because visual shape is something like similar to the when the CRT monitors was there, those days not the LED or LCD computers. I mean, there is most of the desktop with the CRT monitors, and the TV were also had a very similar view, and people thought this is another TV set where you can watch lots of things, and that's true to some extent, but the way things are happening, what people can do, it's very different, but the interpretation, and that's depends on. So what you see is what you get. It's a very important to make it visible, and visible means it's not visually visible for someone. People need to understand it in a way based on their language in order to use it. Okay. So very important concepts. You can learn more this week. Bridging the gap of execution. Yeah. I mean, some of the suggestions are given here. Determine the functions of the device. Tell what actions are possible. Determine the mapping from interaction to the physical movement. Perform the action. Tell it the system's desired state. Determine the mapping from the system state to the interpretation. Tell what state the system is in. I mean, this is the kind of an inner algorithm, how it works when the people start carrying out some actions on the systems. Okay. So then if I come back here, human error, Okay, the other thing. So we know about the two gulf of execution. Human error is related to these two gulf of execution because the two errors could happen. One error is if people don't understand. Okay, if people don't understand something, if their mental model is different, they may make lots of mistakes because due to the lack of the knowledge. Uh, that is what we call the mistakes. Mistakes are kind of a thing that people make when they don't understand. But there are another type of errors called the slips. That happens when the people try to do things in a hurry and they forget. They miss the thing. And the most of the errors are due to that one. Even if you consider the accident, many accidents are due to slips. The driver is a capable, smart driver, but the slips are the main reasons for the accidents. If a beginner, someone who doesn't know how to drive in a car properly, also could make will face an accident, but that may be due to the lack of knowledge, understanding. So when we talk about the human errors, it's important to see these two differences because then it's easy to plan kind of a way to address these two things. So errors are unavoidable. That's we really need to keep in mind. And it is a responsibility of the designers to manage. So what is our intention here is to avoid or minimize errors. Slips, how do you avoid or minimize? The common rule is better interface design. Okay. Mistakes, better understanding of the system. So both these two things must be addressed if our intention is to minimize the errors the user will make when using the system. Okay. Hope you have if you have any question, you can ask. You can put it in the chat box. Okay, moving forward, error avoidance design. This is the kind of concepts comes in the user interaction design. It's a kind of a thing where better to prevent any type of an error than common rule. Minimize the errors, okay, prevent happening that one. So how do we do that one? Design the user interface in such a way that the user can easily build the correct mental model, how the system works. Okay, so the logic is if the user has a good mental model and if he has a good background, he has a good experience of the system, errors could be minimized. And inform, educate the user in advance. So this is another thing. Educated the user. The good systems start with a small mental model. People may not have any experience, but very quickly people will be able to learn it. We call this one a learning curve. Okay. Be flexible with an input format, availability of more than one way to do a thing. Critical options, actions, not to set execute by default. Separate frequent action items. Icons keep dangerous items. Icons away from the frequent use commands. Warn users if actions have irreversible effects. The request reconfirmation, which should not be in a default option. So if I take a simple example, suppose when a person press a button or option like in a delete all, one way is to execute that one. But in a good interface design, usually a confirmation will be required. So the message will pop up on the screen saying, do you really want to delete all? If you say yes, then only it will delete all these things. Otherwise, So that kind of critical operations requires a kind of messaging and the confirmation from the end users. And the same thing comes when you have to type the password for a given thing. People ask to type it twice. So to make sure people have typed what they really have there in mind, since they don't see the characters, they can't see, it's not visible in some cases. Yeah, then error avoidance design, lots of things in the world could happen. But small message could lead to a wrong interaction. Suppose if people say oops instead of enter, people will never wanted to press that button. Yeah, some of the things are very visual and the people can easily identify. Improve the visibility using appropriate color. This is also very important matter. Colors we can use to communicate. I mean the picture as well as the text will communicate one message, but the color will communicate another message. So, so when we interpret many things, we also consider the color of the thing to understand them in a different way. So the simplest example, when something is written in red, it's considered to be danger and very sensitive information where the people will have to know about it. Green, blue, warm colors, all these things are given here. Methods of the error avoidance, okay, it's different mechanisms people can use to design. And one way is what the people call the use of the constraints, okay. For example, inactive menu item is a kind of a constraint. People, depending on their rights, they will not be allowed to do some operations. Design for errors is another approach where you think about all possible errors that could happen and then design based on it. Wizards, have you heard? Have you ever heard something called wizards? What is that? If you have heard, raise your hand. If you know it, what stands for the wizard, just type it here. What stands for the wizard? Any suggestion? Any idea? Have you ever used wizard to do something? Usually, if you have to do something again and again, and if you are trying to repeat the same thing, a common problem, people will make mistakes. So repeating something is possible, people could make mistakes. So objective of a wizard is to minimize that sort of an error people make when they have to repeat. So it comes to some extent a kind of a slip. So when you have to repeat again and again. So even people put together some commands and create a batch file or shell script on Linux to execute it as one using a one command. And even in a programming environment, integrated development environment, people have they get this, what we call the basic program. They can auto create program. Nothing works, but the structure will be created. The template is also to some extent is a wizard, even a CV templates and the document templates. And then people just find it very easy to fill the gap and use it. So style wizards, style template, also very useful thing. So the wizard, the main purpose is that. So in the several systems, many systems, they use this technique of a wizard to facilitate the people using it. Have you ever heard this thing? Swiss cheese, I hope everyone have tasted the cheese, but have you ever heard this thing called the Swiss cheese model? This is not only for the interface thing, but general model. That's for the to minimize the human error that could happen. This is a question for the last year paper. Okay, I marked it few days ago. I have asked, some people have replied, some people have not done. What is this Swiss cheese model? As a model, this describes the basic structure, how it works. And this comes with several other things. It contains several layers, one thing. And every layer has some specific purpose. People consider the possible error that could happen as in a whole. So interaction, this layer protect the user, but if the user interactions comes to this particular hole, it means it goes to the next level. So the penetration could be happen. So it's like in a protecting something. People say put in a like in an army camp. Okay, I have seen that they have a several layers, protection circles to protect the core resource. So in this case, Swiss cheese model is protecting the user using several layers. However, the worst thing could happen. What is the worst thing? We call it a catastrophic situation. Yeah, several errors are aligned. Then it will create a path from the top level to the bottom level. The people may go and could do sometimes dangerous action. So Swiss cheese model describe this mechanism. I think it's a very important to prevent. Okay, at a one layer, error could result going through it, but at least at the next layer, the system should prevent such errors occur. Any suggestion, views on this one? I welcome. The details are given here. Here is a catastrophic situation. Moving to the next one, error prevention guideline. This is a famous concepts comes here. Error prevention, messages are visible, plain language, describe them. Let's go through. Okay, so I'm not going to describe things in detail. So error message design, okay, error prevention guideline, where people can take it as a precaution. And another thing, error message design. Okay, when an error is occurred, usually it should be informed. I mean, the worst thing, if the error is not informed to the end user, he may think everything is correct and it may lead to a worse situation. So system should understand, if possible, whether this is an error or not. If it is an error, it should be notified and relevant action should be taken. However, error message design is very important because it's not a human being, a machine which is trying to communicate this error message to the end user. So in that case, should be very careful with respect to the wording, not another difficult thing. And so there are some small things that the people can adopt whenever they do it. For example, make the system take the blame for errors. Okay, and they usually don't blame. The message should not be criticizing the end user. So that will create some sort of a bad relationship between the user. Okay, always try to interpret the things the wrong side is on the user. Do not use all uppercase letters. Main reason that is considered as a bad way of saying something. Use attention grabbing techniques cautiously. Blinking messages, flashing messages. Okay, that will. Do not use more than 4 different font sizes per screen. Because that's also will find it very difficult. Do not overuse audio and video. Okay, it's not a Torana type thing. It has to be very practical, logical. Things should be provided. Use colors appropriately. Make use expectation, use of expectation. So simple and sweet. It's also another small thing. So these are the people really need to consider when they are designing errors. But here are some good examples, bad error messages for you to see it. Okay. This is what I mentioned, informing the user about the errors and important errors with the mistakes. Okay. So there are some examples. So please go through. I mean, very important and interesting. Yeah. So that's the whole thing about the errors. If any question, you are welcome. Okay, I'll move to the ergonomics. So you can see why ergonomics is important. Okay. People don't take these things very serious. Now the situation is becoming worse due to the pandemic situation. People keep on sitting in front of computers, taking things seriously. So people spend many hours in front of computer without thinking about the impact on their bodies. So that's one thing. Careless use of a device without considering the effect on the human body could repetitive stress or strain injuries. Okay. RSI includes in the pain, one eye. Okay. And ergonomics address these issues by improving the product design or workspace engagement. So in this section, I think it's the main thing. I hope everybody knows these things, how to sit in front of a computer and how to use it. And this is the only way it should be done. I don't know whether all of you are on something like in this way at the moment, but I am not. So that is not good. So here are the bad ways to use computers. So sometimes we forget the way we are using the computers, but always keep your posture like this and use it, the computer. Okay, very important. Original way or ergonomics is a little bit of the engineering stuff where There are lots of theories there, and this is a very famous rule. Every 20 rule. So it says every 20 minutes, take a 20-second at least a break, and look at something 20 feet away. That's very, very important. Benefits of the ergonomics, I think it's the details are given. You really need to go through them. And I also have some YouTube links for you to know about these benefits, details, and some proper use of hands, common health issues, and some ways to address ergonomics. They are given. Arrangement of the controls and the displays, surrounding environment, health issues, use of tools. So it's not in a one way, but could be considered as in several ways. Protect your eyes when using a computer, it's important. Ergonomics is not only desktop or laptops, mobile devices more critical. Now people are facing lots of issues. They know these things, but they forget to do these things. So that is the worst thing or bad thing. So probably the system can inform the users in some cases. Yeah. So that is in a very brief section about the ergonomics. Any ideas, any question, any comments? I'm happy to hear before I move to the next one. Give me 1 minute for that before I move. So if you have a question, think about the question and put it in the chat box. We are taking 20-20-20 rule now, okay? Okay, let's move to the next section. Interaction styles. So what is the interaction styles? Okay, way people are interacting with the system. There are different ways we can describe styles. Okay, I mean in the common world we call the fashion. different styles people use. So these are some of the popular styles. There are more. I'll describe them just for you to understand. So the first one, most popular one, what we call the command line interface, CMD. Before the graphical user interface, people used this method to communicate with the computers. Yeah. Especially in some cases, it's still the command line interface is better for some tasks. People do it. For some other tasks, it's not good. Comparison of a given a CLI is given here. So you have to go easy control, multitasking, space, low resources, scripting, remote access. Some are good, some are bad. Details are given here. Then the other style is based on the kind of the very initial stage, which comes with a menu base interfaces, basic based on the WIMP components, Windows icon menu pointer. So menus are not standalone, it comes with the other components. So there are different types of the menus where things happen now, like the things like that. You can have menus within a where people can control the device, or menu can be integrated within a different tabs mechanism. Even this is the what you can see on the current Office applications, which comes with the on top. Is earlier version of even the Microsoft Word was the menu based interfaces, but now we call the ribbon. The ribbon has like a tab and a menu within several interfaces. The other style called the natural language, NLP. I mean, the people can talk, people can listen, people can use those text to voice, voice to text mechanisms to interact. Query based interfaces, I mean, even the open search, like on Google, is an advanced type. On the other hand, people can use an SQL type, structured query languages to type it. Also, a form could be used like this to query it by putting the condition and retrieve. Even graphical things could be searched by drawing in a particular picture and then search things which are similar to that, like this. So form fields, form-based query interfaces are also famous, especially if the people don't know the underlying the language like the SQL. You can replace using the form fields interfaces. Okay. So there are advantages as well as disadvantages. And the complex form-based query is also possible. So the example is given here. And how the queries works flow is also given. Different interaction style on the QBE. I mean, especially if you have to design something, depending on the users, you'll have to create a very simple interface. I was evaluating in a project last week, one of a student, and he was designing a system to record the police complaints. Okay, without going to the police station, someone can log in into a system and type the message. I mean, they input the complaint to the police station. However, the issue is what I saw there is the public users don't know much about how systems work. If we ask them to put lots of details on the one single page, it will be very difficult. But if they use in a system like this, where people can use this type of arrows to go small thing at at a time, collect the details one by one. So interface become way more interactive and very easy to understand. So that model are good, especially for a public interfaces where you find in a group of heterogeneous users. Heterogeneous means the people with different backgrounds. Okay, we talk about that later. Designing a form-based interfaces is an exercise that you can do. Okay, how to develop a small form using that one. So we will have a kind of a small tutorial before we do this one. Design for form-based interfaces. Some of the suggestions are given. And the complex one, what are the different components are given. So you need to carefully go through them. Elements, forms-based interfaces, Windows menu, toolbar. These are the basic stuff. Canvas, regions, blocks, text items. Radio buttons, scroll bars, and checkboxes. Then spreadsheet-based interfaces are also a very popular one. Spreadsheet is in a different way of interaction can be built, especially when people wanted to analyze in a data set using some mathematical relationship. Yeah, so those are the basic things which I have presented as the for the interaction, different interaction styles. Then the last part of here is the Vim components for interaction. And Windows icon menu pointer. Windows, in its case, we talk about so many things. Okay, basic components, scrolls, title bars, things like that. And the widgets we call small components which we can attach on the interface to create a different flow of interaction, like on a button. This is one thing, and a button with this kind of a small icon, then you can provide a better visual appearance and also triggers an easy interaction. So some components are given here as an examples. Point and click interface. It's where people have a multimedia or hypertext or multimedia based interfaces, like in the web browser, on the web page. We call point and click interfaces. Okay, hypertext. Clickable text is known as a hypertext, and even the web pages you find the similar things. So this 2D to 3D pair is also very, very important. And 3D are more. Which one is better, 2D or 3D? In a 3D world, things could be more interactive and the user may feel it. Like the way things appears on in the room or working space. Google Maps is a good example. Sorry, not the Google Map, Google Earth, okay? And then here is the new style of the WIMP is what we call the ribbon-based interaction. So even the new Office 360, you will see something like this. Icons has become a popular style, especially on the mobile applications. All the mobile application apps tabs, you see interfaces with these icons. Pointers are also important. The traditional menu is this one, but today you don't see something like that, where we have anyway, when I say the menu, different types of the menus are given. Menu styles, that the way things are organized, and scrolling menus are also listed like this. Viewing and hierarchical menus also possible like that, where the people can indicate the status. Details about the advantages and disadvantages. Even also the buttons. I hope the basic stuff, but important to have an idea. And the people can combine some widgets in this way and to combine and provide a better interaction like that. Toolbars, okay, toolbar and a menu combined in a ribbon. Dialog boxes where the people can provide like selections and then okay, apply, cancel, go to the advanced and things like that. Behavior is defined where during the interactions is possible. How many? Okay, for example, favorite. Okay, here we call a radio button. Only one could be selected. Here, check boxes, many things. So it's a more complex. Here it's a straightforward. So depends on that. So sometimes people don't encourage this kind of model, but especially if it is go for a large public, it's better to go for the radio button approach. Future of the interfaces styles are what we call the touch-based natural interaction, where the people will be able to do the drag and drop from one device to another device, not on the same device. So those things here, if you can watch this small video, you will get an idea.
We're 25, 26 years after the advent of the Macintosh, which was an astoundingly seminal event in the history of human-machine interface and in computation in general. It fundamentally changed the way that people thought about computation, thought about computers, how they used them, and who and how many people were able to use them. It was such a radical change, in fact, that the early Macintosh development team in 82, 83, 84 had to write an entirely new operating system from the ground up. Now, this is an interesting little message, and it's a lesson that has since, I think, been forgotten or lost or something, and that is, namely, that the OS is the interface. The interface computation in general. It fundamentally changed the way that people thought about computation, thought about computers, how they used them, and who and how many people were able to use them. It was such a radical change, in fact, that the early Macintosh development team in 82, 83, 84 had to write an entirely new operating system from the ground up. Now, this is an interesting little message, and it's a lesson that has since, I think, been forgotten or lost or something, and that is, namely, that the OS is the interface. The interface is the OS. It's like the Land and the King and Arthur. They're inseparable. They are one. And to write a new operating system was not a capricious matter. It wasn't just a matter of tuning up some graphics routines. There were no graphics routines. There were no mouse drivers. So it was a necessity. But in the quarter century since then, we've seen all of the fundamental supporting technologies go berserk. So memory capacity and disk capacity has been multiplied by something between 10,000 and 1 million. Same thing for processor speeds. Networks, we didn't have networks at all at the time of the Macintosh's introduction. And that has become the single most salient aspect of how we live with computers. And of course, graphics. Today, $84.97 at Best Buy buys you more graphics power than you could have gotten for $1 million from SGI only a decade ago. So we've got that incredible ramp up. Then on the side, we've got the web and increasingly the cloud, which is fantastic, but also in the regard in which an interface is fundamental, kind of a distraction. So we've forgotten to invent new interfaces. Certainly, we've seen in recent years a lot of change in that regard, and people are starting to wake up about that. So what happens next? Where do we go from there? The problem, as we see it, has to do with a single simple word, space, or a single simple phrase, real-world geometry. Computers and the programming languages that we talk to them in, that we teach them in, are hideously insensate when it comes to space. They don't understand real-world space. It's a funny thing, because the rest of us occupy it quite frequently and quite well. They also don't understand time, but that's a matter for a separate talk. So what happens if you start to explain space to them? One thing you might get is something like the luminous room. Luminous room is a system in which it's considered that input and output spaces are co-located. It's a strangely simple and yet unexplored idea, right? When you use a mouse, your hand is down here on the mouse pad. It's not even in the same plane as what you're talking about. The pixels are up on the display. So here was a room in which all the walls, floors, ceilings, pets, potted plants, whatever was in there, was capable not only of display, but of sensing as well. And that means input and output are in the same space, enabling stuff like this. That's digital storage in a physical container. The contract is the same as with real-world objects in real-world containers. Has to come back out, whatever you put in. This little design experiment that was a small office here knew a few other tricks as well. If you presented it with a chessboard, it tried to figure out what you might mean by that. And if there was nothing for them to do, the chess pieces eventually got bored and hopped away. The academics who were overseeing this work thought that that was too frivolous, so we built deadly serious applications like this optics prototyping workbench, in which a toothpaste cap on a cardboard box becomes a laser. The beam splitters and lenses are represented by physical objects, and the system projects down the laser beam path. So you've got an interface that has no interface. You operate the world as you operate the real world, which is to say with your hands. Similarly, a digital wind tunnel with digital wind flowing from right to left. Not that remarkable in a sense. We didn't invent the mathematics, but if you displayed that on a CRT or a flat panel display, it would be meaningless to hold up an arbitrary object, a real-world object in that. Here, the real world merges with the simulation. And finally, to pull out all the stops, this is a system called URP for urban planners, in which we give architects and urban planners back the models that we confiscated when we insisted that they use CAD systems. And we make the machine meet them halfway. It projects down digital shadows, as you see here. And if you introduce tools like this inverse clock, then you can control the sun's position in the sky. That's 8 a.m. shadows. They get a little shorter at 9 a.m. There you are, swinging the sun around. Short shadows at noon and so forth. And we built up a series of tools like this. There's intershadowing studies that children can operate, even though they don't know anything about urban planning. To move a building, you simply reach out your hand and you move the building. A material wand makes the building into a sort of Frank Gehry thing that reflects light in all directions. Are you blinding passersby and motorists on the freeways? A zoning tool connects distant structures, a building and a roadway. Are you going to get sued by the zoning commission? And so forth. Now, if these ideas seem familiar or perhaps even a little dated, that's great. They should seem familiar. This work is 15 years old. So this stuff was undertaken at MIT in the Media Lab under the incredible direction of Professor Hiroshi Ishii, director of the Tangible Media Group. But it was that work that was seen by Alex McDowell, one of the world's legendary production designers. But Alex was preparing a little sort of obscure indie art house film called Minority Report for Steven Spielberg, and invited us to come out from MIT and design the interfaces that would appear in that film. And the great thing about it was that Alex was so dedicated to the idea of verisimilitude, the idea that the putative 2054 that we were painting in the film be believable, that he allowed us to take on that design work as if it were an R&D effort. And the result is sort of gratifyingly perpetual. People still reference those sequences in Minority Report when they talk about new UI design. And that led full circle in a strange way to build these ideas into what we believe is the necessary future of human-machine interface. The spatial operating environment, we call it. So here we have a bunch of stuff, some images. And using a hand, we can actually exercise 6 degrees of freedom, 6 degrees of navigational control. And it's fun to fly through Mr. Beckett's eye. You can come back out through the scary orangutan. That's all well and good. Let's do something a little more difficult. Here we have a whole bunch of disparate images. We can fly around them. So navigation is a fundamental issue. You have to be able to navigate in 3D. Much of what we want computers to help us with in the first place is inherently spatial, and the part that isn't spatial can often be spatialized to allow our wetware to make greater sense of it. Now, we can distribute this stuff in many different ways, so we can throw it out like that. Let's reset it. We can organize it this way. And of course, it's not just about navigation, but about manipulation as well. So if we don't like stuff or we're intensely curious about Ernst Haeckel's scientific falsifications, we can pull them out like that. And then if it's time for analysis, we can pull back a little bit and ask for a different distribution. Let's just come down a bit and fly around. So that's a different way to look at stuff. If you're of a more analytical nature, then you might want actually to look at this as a color histogram. So now we've got the stuff color sorted. Angle maps into color. And now if we want to select stuff, 3D space, the idea that we're tracking hands in real space, becomes really important because we can reach in, not in 2D, not in fake 2D, but in actual 3D. Here are some selection planes, and we'll perform this Boolean operation because we really love yellow and tapirs on green grass. So from there to the world of real work. Here's a logistics system, a small piece of one that we're currently building. There's a lot of elements, and one thing that's very important is to combine traditional tabular data with three-dimensional and geospatial information. So here's a familiar place, and we'll bring this back here for a second. Maybe select a little bit of that, and bring out this graph. And we should now be able to fly in here and have a closer look. These are logistics elements that are scattered across the United States. One thing that three-dimensional interactions and the general idea of imbuing computation with space affords you is a final destruction of that unfortunate one-to-one pairing between human beings and computers. That's the old way, that's the old mantra, right? One machine, one human, one mouse, one screen. That doesn't really cut it anymore. So in the real world, we have people who collaborate, we have people who have to work together, and we have many different displays, and we might want to look at these various images. We might want to ask for some help. The author of this new pointing device is sitting over there, so I can pull this from there to there. These are unrelated machines, right? So the computation is space-soluble and network-soluble. So I'm going to leave that over there because I have a question for Paul. Paul is the designer of this wand, and maybe it's easiest for him to come over here and tell me in person what's going on. So let me get some of these out of the way. Let's pull this apart. I'll go ahead and explode it. Kevin, can you help? Let me see if I can help us find the circuit board. Mind you, it's a sort of gratuitous field stripping exercise, but we do it in the lab all the time. All right. So collaborative work, whether it's immediately co-located or distant and distinct, is always important. And again, that stuff needs to be undertaken in the context of space. And finally, I'd like to leave you with a glimpse that takes us back to the world of imagery. This is a system called Tamper, which is a slightly whimsical look at what the future of editing and media manipulation systems might be. We at Oblong believe that media should be accessible in much more fine-grained form. So we have a large number of movies stuck inside here. And let's just pick out a few elements. We can zip through them as a possibility. We can grab elements off the front, whereupon they reanimate, come to life, and drag them down onto the table here. We'll go over to Jacques Tati here and grab our blue friend. Put him down on the table as well. We may need more than one. And we probably need a cowboy, to be quite honest. Yeah, let's take that one. You see, cowboys and French farce people don't go well together, and the system knows that. Let me leave with one final thought, and that is that one of the greatest English language writers of the last 3 decades suggested that great art is always a gift, and he wasn't talking about whether the novel costs $24.95 or whether you have to spring $70 million to buy the stolen Vermeer. He's talking about the circumstances of its creation and of its existence. And I think that it's time that we asked for the same from technology. Technology is capable of expressing and being imbued with a certain generosity. And we need to demand that, in fact. For some of this kind of technology, ground center is a combination of design, which is crucially important. We can't have advances in technology any longer unless design is integrated from the very start, and as well as of efficacy, agency. We're, as human beings, the creatures that create, and we should make sure that our machines aid us in that task and are built in that same image. So I will leave you with that. Thank you.
Okay, that's I just wanted to show how things will happen. In the future, as well as how the different interaction styles will work on. So that's the main thing I just wanted to today's for the session. I wanted to talk about part of the session. Any question, anything that you wanted to ask, so you can see the details on the slides, and let's go here. I will activate the next thing called the pact analysis, and we'll update today. So you can watch those who have gone through the next big session, pact analysis, and we'll also activate the small piece that comes with this one. I will update that one with the new deadlines, and will do. So that's all what I am planning to do today. Any question, any comments, anything anyone wants to ask? Okay. So we will finish the today's discussion with that. If there is a question, and also I request all of you to participate the discussion forums. Okay. We have a discussion forum. Yes. No discussion at the moment. Okay, but any question, any comment, please do participate when you go through. This is natural that things comes to your mind, and that participation I count for the continuous assessment. Yeah. With that, I will stop today's session.